Okay, so example 9, here we're going to use a Venn diagram, and so you're going to be given a Venn diagram, and the goal is to find each set. So first let's describe the Venn diagram. So this is the universal set, and we've been talking about two subsets, right? A and B. So this first circle is going to be A, right? And I know A is on the outside. I just don't want it to be too cumbersome, but I mean, A is really here, but again, this is my A and this is my B. So this is B. And we have some values in here. So in A, I have 2 and 3. Here I have 5. Here I have 7, 11, and 13. And on the outside of A and B, I have 17 and 19. And I also have a Roman numeral 1, 2, right, is in the intersection, and then 3. And then we also have 4 here. So here, this Roman numeral is representing everything in this piece, right? Not the whole A, but just this piece. So in other words, 2 and 3, right? Roman numeral 2 is here, and so forth. And we're going to go ahead and compute these specific sets. Okay, so let's make that a little bit, well, not too small. Okay, so the first set I want you to find is the intersection of A and B. Well, what's the intersection of A and B? Well, it's right there, right? That's the intersection. So that is, the answer is just 5. So it's 5, and this is a set, so we have to put set notation around it. Okay, and this is also known as the singleton set, right? Because there's only one element in there, right? Singleton, single meaning one. So that's it. B is in the intersection of A and B, and you want to take the complement of that. Well, the nice thing is that we already found A intersection B, right? Well, I just underlined it. So the complement just means everything that's not in A intersection B. And so basically it's everything but the 5. So we're going to write the rest of the values. And it looks like 2, 3, 2, 3, well, let's see, let's go in order. 5, 7, 11, 13, 17, and 19. And I don't like the way that looks, so I'm going to rewrite it. And that's a 5, right? Everything in the set except 5. Part C is what is the union of A and B. And so remember, the union is all the elements in A, right, or in B. So the elements in A or B, well, first let's write the elements in A. So that's 2, 3, and 5. So 2, 3, and 5. And now we look at set B, right? And, well, what's B? B is 5, the collection, right? 5, 7, 11, and 13. But notice, right, 5's in common with A and B, so we don't want to write another 5 here. So we just write 7, 11, and 13, right? So that is A union B. And the next one is, okay, so A union B now, but you're going to take the complement. So again, the complement is everything, everything in the universal set except, right, this guy. So, well, we just found A union B, right? It's all of this. So that complement means I want everything but these numbers. Well, what are the only numbers left? Well, they're right here, right? I mean, we don't want these, so we take these guys. And let's see, we have That looks like above 17 and, just to make sure, 17 and 19. So 17 and 19. So E, so we have E and F. So A prime union B, what does that look like? Let me make it smaller so I just have some room. Okay, so A prime union B. So first I want to find A prime. So what's the complement of A prime? Okay, so I'll first start with that. So, well, the set A, right, it has 2, 3, and 5. So I want everything but 2, 3, and 5, right? Because the complement is all, I mean, if you basically take this rectangle and cut off this circle, literally cut it out with the scissors, you don't have this part anymore. You just have 7, 11, 13, 17, and 19. And union B, so let me just go ahead and write B. B is 5, 7, and make this smaller so I can have room. 5, 7, 11, and 13, right? This guy is my B. So what's the union of A prime union B? Well, remember, you take the first set, so that's 7, 11, 13, 17, and 19, and then you list anything, right, in B that's obviously not in A again, or A prime. So 5 is not in here, so I can write 5. Notice 7, 11, and 13. 7, 11, they're already in here, so we don't want to repeat it. So, well, that's just 5. And then we can rewrite this. I mean, we can write the 5 so it can be in increasing order, but it doesn't have to be. So this is fine. And finally, F is A union B prime. So A is, well, just from looking at the picture, it's 2, 3, and 5, right? Those are in circle A. That's a 2. And intersected with B complement. So it's everything but the elements in B. So the elements in B are 5, 7, 11, and 13, right? So we don't want these guys. We want everything outside of the B circle. So that's 2, 3, so not 5, 7, 11, 13, 17, and 19. And we're almost done. Hang in there. I know this is a long problem. Well, what's in common? And it looks like 2, 3, and that's it, right? Because this is a 5. So we just have 2, 3. And that's it. This is example 9, and I'm going to do one more example, which is 10, and then that'll be it.